Hello, I'm Urim Lee, who is the PhD student in GIST. Today I'm going to present about the elimination efficiency of halogenated methylparabens during ozonation and UV hydrogen peroxide treatment of drinking waters. This is the content. Parabens are widely used as antimicrobial preservatives in cosmetics, foodstuffs, and pharmaceuticals. So these compounds are ubiquitous in various water environments. So methylparaben can be rapidly transformed into monohalo and dihalo methylparabens in the chlorination process. So these halomethylparabens can be produced when free chlorination is applied to water treatment plant, but the information on the kinetics or removal rate in oxidation process is unknown. So the objectives of this study is to assess and predict the elimination efficiency of halomethylparabens during oxidation processes such as UV hydrogen peroxide, and ozonation. Detailed experimental methods are shown here. This slide shows the direct UV photolysis rate and quantum yields of halomethylparabens. Especially these bromine-containing halomethylparabens show relatively higher quantum yields than that of others. And the ozone reaction rate constants for the halomethylparabens were measured. This figure shows the second-order rate constant for the reaction of ozone as a function of pH. Overall, the rate constants were strongly pH dependent. This should be associated with the deprotonated state of this phenolic structure. So reasonable prediction curves were obtained by following apparent rate constant calculation equation using measured K and pKa values. And second-order rate constant for OH radical were also measured at pH 7 by competition kinetics method using gamma radiolysis system as a source of OH radical. So this table shows the summary of photochemical and kinetic parameters. For the elimination efficiencies, this graph shows the elimination efficiencies of halomethylparabens during ozonation as a function of specific ozone dose in the two types of drinking water matrices. First is the pre-chlorined water, and second is the sand-filtered water matrix. So near complete eliminations were achieved at low level of ozone dose due to the high ozone reactivity at neutral pH. During the UV hydrogen peroxide treatment, the elimination rates of halomethylparabens were more than 90% at a UV fluence of 1500 millijoule per square centimeter. And in particular, bromine-containing halomethylparabens showed more than 90% eliminations by UV alone treatment due to the high photolysis quantum yields. Finally, these figures show a prediction of elimination rate using kinetic model based on the photochemical and kinetic parameters obtained from this study. The elimination degrees of halomethylparabens during UV hydrogen peroxide treatment were well predicted. And summaries and conclusions. Photochemical and kinetic parameters of halomethylparabens were investigated. Due to the phenolic moiety of parabens, the ozone rate constant showed significant pH dependence. And during the ozonation process, near complete elimination were achieved at a low level of ozone dose in drinking water matrices. And during the UV hydrogen peroxide treatment, the elimination efficiency of halomethylparabens were more than 90%. In particular, bromine-containing halomethylparabens showed more than 90% eliminations by UV alone treatment. A kinetic model based on the photochemical and kinetic parameters could successfully predict elimination degree of methylparabens and its halogenated methylparaben during UV hydrogen peroxide treatment. Overall, the ozonation and UV hydrogen peroxide AOP are found effective in controlling parabens and their halogenated product in drinking water treatment. So this study was funded by the Korea Ministry of Environment. And thank you for your attention. If you have any questions, please feel free to contact me. Thank you.